solution is, for the circuit shown, the clock frequency is F0 and the duty cycle is 25%. Okay, this is the clock and the frequency is F0, duty cycle is 25%. But the signal at the Q output of the flip-flop is, this is the JK flip-flop and this is the output Q. Yes, now they are asking for the signal at the Q output of the flip-flop. In the problem, they are asking the frequency and duty cycle of the output. Okay, these are the options. And they are given the clock frequency as F0 and the duty cycle of the clock frequency signal as 25%. Okay, let's go for the solution. Okay, see here the counter is a 2-bit binary counter. When the type of the counter is not mentioned, you have to consider it as up counter. It is a 2-bit up counter. And consider the outputs of the counter Q0 and Q1. Just I'll write the outputs. Consider Q0 as LSB and Q1 as MSB. And here the same clock is applied for counter and flip-flop. Okay. So now, before the application of clock, these two will be 0. After the application of clock for one time, the outputs are 0 and 1. For second clock, the outputs are 1 and 0. For the third clock, the outputs are 1, 1. And for the fourth, this sequence will repeat. So it has 4 states. That is the reason it is called 2-bit up counter. Now if you observe, this Q0 is connected to both J and K inputs. And here Q is the output. So okay, now you can explain all this circuit working and you can find the frequency of output and duty cycle with the help of some waveforms. Okay. Now you can explain the operation of this circuit and you can find the frequency of the output and duty cycle of the output with the help of waveforms. Let me draw the waveforms. And another point, assume that the clock here is a positive edge triggered clock. Positive edge triggered clock. Okay, let me draw the waveforms. So let me explain the waveforms. This is the clock, positive edge triggered clock, and this is the waveform for Q0. So when there is no clock, Q0 is 0, and whenever clock 1 is applied, Q0 becomes 1 and that transition happens at positive edge. Yes, like this. Then for clock 2, yes, it goes to 0. So this is the clock 2 positive edge, so it goes to 0. For clock 3, it goes to 1. So this is the positive edge for clock. So it goes to 1. And then for 4 again, it goes to 0. So it will be continued for successive clock pulses. Okay. Then I'll see what is the output Q. Okay. So what is our circuit actually? This is our circuit. Here, Q0 is connected to J and K. Okay. So first see. In this state, when there is no clock, what about Q0? Q0 is 0. Okay, Q0 is 0. Then, what about J and K? J, K, both are 0. As J and K are 0, what about Q? Q is 0. So, Q is 0. So, up to this it is Q 0. Up to this. Whenever Q0 is 1, your J and K are 1. So now at this clock pulse, first clock pulse, what happens at the positive edge? What about your Q0? Your Q0 is 0 only. So as Q0 is 0, again your J and K are 0. So the circuit will remains at 0 only. And now this, at this edge, so at this edge, your Q0 is 1. See here very carefully. as it is positive edge triggered clock, at the first positive edge to consider Q naught as 0 only. In the you have to consider the value for Q naught as its previous. At the second clock pulse positive edge, only you have to consider Q naught as 1. Then at this, after this positive edge only, you have to consider this goes to 0 state. That is the point. Again see here. Here also at the third clock pulse, you have to consider Q naught as 0. Means at the positive edge of the clock, consider it as 0. Whenever it crosses this positive edge, you have to consider it as 1. And that remains up to this. Okay. So in that way, yes, this is 1 and this is 1. And this is also 1 and this is 0. At the second clock pulse positive edge, what will happen? Your Q naught is 1 and that 1 is applied for J and K. So now J and K are 1, then your JK flip-flop will toggle. Okay, so it goes to 1 state from 0. Okay, that state will remain. Okay, next for this positive edge of the third clock pulse, what about Q naught? Q naught is 0. Means J and K are applied with 0. Okay, so as J and K are 0, the JK flip-flop output will remain same as previous. That's why it gets continued. Okay, and now at the fourth clock pulse positive edge, the Q naught is 1 and that is given to JK. So now as JK are 1, what will happen? The JK flip-flop will go from 1 to 0. Now what will happen at this positive edge? You have to consider Q naught as 0. As Q naught is 0, J and K are 0, means the output Q will remain in same state. Now at this positive edge of the clock, Q naught is 1. Now JK are supplied with 1. So as JK are 1, what about the output of JK? Toggle output. Okay. So hence it goes 1 from 0. See, this is your Q. The output waveform Q. Okay. Now suppose if you consider the clock time period as T0. Now, what about the time period of our output Q? Let it be T. Q output. The time period T is, if you observe this period, it includes 4 clocks. Totally 4 clocks. Hence it is 40 naught. Okay. Then what is the frequency? Frequency F of output. Yes, as the time period is 4 times of the clock period, frequency is F0 by 4, as time and frequency are inversely proportional. And another point is that is duty cycle. What is meant by duty cycle? Okay, T on by total time. T on means, consider this as on time, and this total as your total time. So what about T on? It is nothing but your 2T0. What about total time? 4T0. It is nothing but 1 by 2. And if you go for percentage duty cycle, it will be 2 into 100. So it's nothing but 50%. Okay. So what is the answer here? You observe the options. Yes, F0 by 4. Frequencies F0 by 4 and 50%. F0 by 4 25%, F0 by 2 50%, F0 25%. So this option is correct.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.